Okay, so we're going to continue using our C-score table. We're going to be looking at finding probabilities today. And then what I mean with the C-score table, remember we have it available in the notes on the module, so you guys can log in. It is this table right here. Okay, we've been working on how to use it. We should know how to use it, and we're going to continue using it today. So we're going to be finding the probabilities for the data given. So let's take a look at our first question. Suppose that scores X on a college entrance examination are normally distributed. Okay, so once I hear normally distributed, I think the normal distribution, so that looks like a bell. Remember, I'm looking at this distribution. It says it has the mean of 550. Let me write down what information I'm getting. My mean is 550. And then a standard deviation of 100. Okay. I'm going to say my standard deviation is 100. Find the probability the student gets at most. Okay, so at most 523. Okay, so that's my X I'm going to be comparing. 523. Looking at our graph for us to understand, before I even look at our C-score table, looking at our graph, I have my mean here, which is 550. And I want to check, so this is 550. My X that I want to check is 523. And it says at most. So does that mean more than 523? Does that mean less than 523? Well, at most means 523 or less. Okay, so I'm looking for this probability here. Okay, so that gives me an idea what to look for. Okay, now that I have my X, I have my mu, and I have my standard deviation, I need to know my C-score. And I remembered I gave you guys the formula for C-score. Let me write this thing up again. Our C-score is X minus mu over standard deviation. So looking at our case here, my C-score is going to be 523 minus 550 over 100. And whatever I get, I'm going to round it up to 2 decimal places. Okay, so I'm going to use my calculator, 523 minus 550. I'm writing it as a fraction. We can use a calculator I gave you, and it says this is negative 0.27. Okay. The negative sign is because my X value, my 523, is to the left of my mean, right? It's to the left of my mean. It makes sense. In reality, I'm just going to look for 0.27 on my C-score. Remember the left, it just says 523. I mean, my negative sign, it just says 523 is to the left of my mu. Well, I knew that already. So let me look at my C-score, 0.27. Looking at our table here, 0.27. So I have to look on the left at 0.2 connected with the 7 from the top. So 0.2 and then connected with the 7 on top. I get right there 0.1064. Okay, but what does that mean? 0.1064. According to our table or our picture here, what is our 0.1064? Well, that's the area from the mean, so from the center to my C score. So this is actually where my C is. And remember that 0.1064 is the area from the mean to my C score. So I'm going to say this area in here is 0.1064. But I'm not looking for that area. I'm looking for this area. Well, I remembered that half of the graph, so that means from my mean, from the centered, either to the left or to the right, is this whole thing is 0.5. Actually, let me write it outside. This whole red box is 0.5. So the way I'm going to find, I'm going to shade it in blue. The way I'm going to find this blue section, I'm just going to go 0.5 minus 0.1064. Let me type that in my calculator. So 0.5 minus 0.1064. It says this area in here is 0.3936. So my probability of getting at most 523, my probability is, so I'm actually going to write up here, 0.3936. In English, what does that mean? Probability of at most 523 is 0.3936. What that means is the probability, what I'm expected to get 523 or less is about 39.36%. So 39.36% of the people that take the test are gonna get 523 or less. That's what it means. Okay. Let's take a look at the next question. Find the probability that the student gets between 500 and 630. We're still using the mu and the standard deviation from before. So let me write down, what do we have here? Our mu is 550. Our standard deviation is 100. Now I'm going to be checking for two x's. My x is 500 and my other x is 630. So I'm going to be checking for my x for 500. And I'm going to check for an x of 630. Because I'm checking for two x values, I'm going to use two different z-scores. Okay. Just to have an idea what is going on here. Let me graph my normal distribution. Here it is 550 because the average, the mu is 550. I'm going to check 500. 500 is to the left of 550 because 500 is less than 550. And then 630 is going to be somewhere over here, right? This is not drawn to scale. I'm just having an idea. Okay, where's 550? Where is 500? And where is 630? I'm looking for a graph here. And I'm looking for the probability that is in between those two numbers. Okay, so I'm looking for basically this area here. Let me get my different z-scores. Remember I said I have to get two z-score values? For if my x is 500, my z-scored, if my x is 500, I'm going to go 500 minus 550, all of this divided by 100. So my z-scored is negative 0.5. It is negative because 500 is to the left of my mu. So it makes sense. My 630 is to the right of my mu. So I actually expect my z-score to be positive. But let's see, my z-score in here is going to be 630 minus 550, all of this divided by 100. I use my calculator and it gives me positive 0.8. Okay. Let me use my table, my z-score table, and I'm checking for negative 0.5, or in this case, I'm actually checking for positive 0.5 because there's no negatives on my table. 0.5. I have my table here that obviously we'll be checking it. You guys can be checking on your table. Like I said, hopefully you guys printed it, downloaded it, or at least have access to it. I gave it to you guys on the module. Well, I gave you guys the file. So my z-score, it gives me for 0.5, it says 0.1915. So remember, here is my C-scored is negative 0.5 here. And then here at 6:30, my C-score is 0.8. So my C-score of 0.5, it says that this area here is 0.1915. If I look at my table for 0.8, it says 0.2881. So that means that from my mu to my C-score of 0.8, so basically this area, it says is 0.2881. So what will be the whole area? Just add them up. 0.1915 plus 0.2881. And I'm going to say, in this case, my answer happens to be 0.4796. So the probability that on this test, where my mu is 550, my standard deviation is 100, the probability that someone gets in between 500 and 630, it is about 47.96%. So 47.96% of my students that take this test will get a score between 500 and 630. That's what it means. So take a look at this last question here. Suppose the scores X on a college entrance examination are normally distributed with a mean of 560 and a standard deviation of 90. So let me write that down. Our mean is 560. Our standard deviation is 90. A certain prestigious university, so they're kind of picky on their scores, will consider for admission only those applicants whose scores exceed the 90th percentile of the distribution. Okay, only those that exceed the 90th percentile of the distribution. Okay, what are we looking at here? Well, let me look at this as a graph. 90th percentile. I know here on the left, to the left is 0.5. And I'm going to look, okay, what do I need for 90%? It's basically 0.4 more. So I'm going to get 0.4 here. And let's say my C-score is about here. So that means that's 0.1 there, because the whole area under the curve is equal to 1, right? It's 100%. So they're saying they're going to accept whoever the scores that exceed 90th percentile. So they want these scores here. Okay. So it has to be more than 90% of the population. So only 10% are going to get accepted. Very prestigious university. Find the minimum score an applicant must achieve in order to receive consideration for the admission to the university. Okay, 90th percentile. So I'm looking at my C-scores, 0.4. I want to know what's the C-score that gives me 0.4. Because remember, the number that it gives me on the table is the percentage, the area in between my Z and my mu. So I'm going to look for my C-score table, and I'm looking for the value, the table that exceeds. So it's more than 0.4. Okay, so I'm looking at my table, and I see, okay, I don't see a 0.4, but I see a couple of values. You guys can see them there. I see 0.3997 and I see 0.4015. Okay, so I wanted 0.4 or more. Okay, because I wanted to exceed. Okay, so basically the smallest percentage that I see, the smallest probability that I see that is more than 0.4 is 0.4015. That's the first number that I see that it's more than 0.4. What is my C-score in this case? I see is 1.29. Okay, so the C-score that I need is 1.29. Let me come back to my work here, to my, see, this thing just froze for a minute. So the C-score that I need is 1.29. Okay, so I know the average is 560, the standard deviation is 90, and the C-score that I need is 1.29. What is the score that I need? Well, I'm just going to go 560 plus, and I'm going to go plus because it is to the right of my mu. If it was to the left, I would have said minus. So plus standard deviation, but then my C basically tells me how many, well, actually, let me not write my symbol. Let me write the actual number. The standard deviation times 1.29. Our formula in reality is mu plus or minus, because if we're going to the right, it's plus, minus if we're going to the left, standard deviation in times our C score. I'm just going to type this on my calculator. 560 plus 90 times 1.29. So let me see, 560 plus 90 times 1.29. The calculator knows that it has to multiply before it adds. So we'll do the multiplication first. And my answer in this case is 676.10. Now we write 676.1, it's the same thing, okay? So what is the score? The mean is 560, the standard deviation is 90. The score that I need to score in order to beat 90% of the people, I have to score at least 676.10.